The first problem is going over the concept of a z-score. We see that Rebecca scored a 74 on her stats midterm, where the class average was an 80 and there was a standard deviation of 6. To find a z-score, we need to figure out how many standard deviations the observation is above or below the mean. So we can do this on the calculator. The formula will always be observation minus mean, and then this total right here is taken over the standard deviation. Now, if you'll notice, 74 is exactly 6 lower than 80. Just take a look right here. If you go down 6 from 80, you will get to 74. So the z-score literally tells us how many standard deviations an observation is above or below the mean. And that's an important concept to know. So when we see this, she was 1 standard deviation below the mean, so her z-score is -1. The mean weight of a breed of yearling cattle is 1,066 pounds. Suppose the weights are normally distributed with a standard deviation of 82 pounds. How many standard deviations from the mean would a steer of 1,000 pounds be? Now, important to do here, we just need to figure out how far it is away. We can take observation minus mean. This will get us how far it is away. But let's go ahead and figure out how many standard deviations it is away. A standard deviation is 82 pounds. So we need to take this answer right here and divide it by 82. It is -0.08 standard deviations below. And it wants it to 2 decimals, so this will work properly. So it is this many standard deviations below the mean, and that's what they've written it. So its z-score is -0.8. But we could also say it's 0.8 standard deviations below. Same concept there, but in terms of a z-score, we would say its z-score is -0.8, and that would automatically give the connotation that it is that many standard deviations below the mean. To figure out which one is more unusual, you just need to figure out which one is further away from the mean in terms of standard deviations. And if you look, this mean right here is closer to 1,000 than it is to 1,250. You can do the math if you like, but 1,250 is definitely more unusual because 1,066 would be closer to 1,000. Whatever is further away from the mean would be more unusual and have a higher z-score. Now, we must use the empirical rule to solve this problem. Remember, 68, 95, 99.7. Very, very important. I can't stress how important this is. Should know those numbers right away. So let's take a look right here. We have the mean of 25.8 and the standard deviation of 6.2. Which of these is appropriate? Well, we see 25.8 at the center of all these, and then we need to go up and down 6.2 each time. It looks like this one will be correct, because if you notice, this right here, and you sometimes have to zoom in to see it a little bit better, but this one right here is too small between each standard deviation, and the other one's too big. So the one that is just right between all the standard deviations, as in it should go up 6.2 each time. So then we'll use this to solve the answers. And drawing pictures like this on the test is key. You want to be able to put the mean in the center of your normal curve and then go up 3 standard deviations and down 3 standard deviations. This is a big tip for the test. I usually write in 0, 1, 2, 3, -1, -2, -3. And those are just the z-scores associated. So at this point, if I told you the z-score for some car was 2, you could tell me it got 38.2. Very easy to do this, and it really helps and makes sure you get a lot of answers correct. What is the central 99.7? Well, that's in between positive and -3 standard deviations, because you can see it right here between negative and positive 3. So we can go ahead and type in the answer right here. There we go. What percent of autos should get more than 32 miles per gallon? And I have a trick for this. So right here is 32. In between, and I do this with my hands sometimes, I hold it in between my hands. In between here is 68. What is total outside? Total outside of 68 is 32. It must add up to 100. So in here and in here, and these technically go all the way out. They don't end in between because it goes all the way to the right and all the way to the left. So inside 68, outside 32, and we only want 1/2. So the answer is 16. And that is one of the key ways to do these questions is to remember, go inside, out, and then half if needed. So what should get between, what percent should get between 32 and 38.2? Right now we're looking at this area right here. And this is tough for some people because this comes down to really breaking down the normal curve. And the answer is 13.5, but how do I know that answer? Well, let's take a look. We just figured out from here over is 16. Remember, from right here over is 16. Now we only care about between here and here. How about from here to here is 95? What is total outside of 95? That would be 5. 5 is total outside. If 95 is on the inside, 5 is total outside. So what is 1/2 of that? 2.5. So from here over is 2.5. So follow me. If 16% is from here over, and 2.5 is from here over, then 13.5 is in between here, because 13.5 and 2.5 add up to 16. So the answer will be 13.5. The best 2.5, and we actually just figured out the answer for this because we figured out 2.5 is from here over because 95 in the middle, 5% total outside of this, 2.5 from here over, 2.5 from here down. So it is at 38.2. And as you can tell, this picture helps a lot to have it. On to the last question. Wow, that's a lot of writing right there. So with this in mind right here, let's take a look. We have a normal model with a mean of 10.8 and a standard deviation of 4.1. So this one automatically is wrong because it doesn't have 10.8 at the center. And this one is wrong because it has 68 on the wrong number line. So it's not between -3 and +3 standard deviations. So this has to be right here. So process of elimination. What size would you expect the central 68% that's within ±1 standard deviation? And let's go with 6.7 to 14.9. Now, I can't reiterate this enough. If you were given this question on a test, you would need to draw this out. So it's in your best interest sometimes to practice drawing these because if we say it's normally distributed with a mean and standard deviation, you need to draw this and then put in your 68, 95, 99.7 rule. And that is really good test practice, especially doing these right now, trying to do the quiz, because you would not usually get a graphic like that on the test right away. Using the 68, 95, 99.7 rule, blank percentage trees should be below 6.7. And right here, 6.7, this is just like the problem we just did. We have 68 in the center between this. So that means 32 is outside. If 68 is inside, 32 is outside. And on one side is 16, because 16 has to be below here and 16 above here. So 16%. You get used to these numbers after a while. About what percentage of these trees should be between 14.9 and 19.0? So 14.9 and 19.0. We have the same question again, and you can break it down. There's a lot of ways to break this down. I'm going to do a different way this time. Since we have 68 in between here and 95 here, if you take out the 68 from the 95, you get 27, but it goes over the two sides. See how 68's in the middle? 95 goes from here to here. That leaves 27 between here and here. Cut 27 in half, and you get 13.5 here, 13.5 here. One of the things that you should really practice, and I'll show this at the end, is you should break down the normal curve and into its parts to show the numbers. And if you can do that, you're doing pretty well. And I'll show that at the very end here. Using the 68, 95, 99.7 rule, about blank percent of trees should have diameters over 19. So let's go check this out here. Over 19, that is between 95, and so if 95 is on the inside, 5% is on the outside, because 5% has to be in the areas from here down and from here over, but we have to cut that in half, so it's 2.5. 2.5, and we've done it. Be careful when it says above or below, because you have to watch out. It could say below, and if it said below, it'd be 97.5. That's one of the ones that often tricks people. We might say below that point, and if 2.5 is above where I have the cursor, then 97.5 is below. Let's take a look at that curve now. So this is the empirical rule broken down, and you'll notice we can find 68 by adding up these numbers right here. 68, if you add 34 and 34. Remember the 27 I found earlier, it'd be 13.5 plus 13.5. Well, you add 27 to 68, you get 95, and then we could add on to the 95, we need to make 99.7. So now we get 4.7. 4.7 cut in half is 2.35 and 2.35. And then the remaining 100%, or remaining 0.3 to get to 100%, would be contained all the way out to infinity on both sides, negative and positive infinity. Now this is the curve broken down, and if you notice the numbers repeat, going 0.15, 2.35, 13.5, 34, and they add up to 50 at this point. There's 50% by the middle. There's a lot of important things to know here. If you add this up, you can do halves. I guess this is another good way to do it. If you want to figure out what is there, you can just take half of 68, which is 34, and then half of 95, which is 47.5, and you'd get to right here, and then half of 99.7, and you're going to get 49.85 right here, and then when you get to here, you've got 50%. So you can add it up. There's so many ways to add it up. Adding it up this way, you'll notice 0.15, because that would be 99.85 here over. That's the remaining on that side. And then if you add to here, you get 2.5, because 97.5 remaining on the other side. Adding up to here, you get 84. And then finally, you get to 50% again. So many ways to do this. You need to practice and make sure you could fill this out, because it can really help on some of the test questions to be able to just jot down these numbers. If you know it really well, you can say 0.15, 2.35, 13.5, 34, 34, 13.5, 2.35, 0.15. And as my students will tell you, I can do that without looking at this, and it's really good if you get down to that. But right now, if you know 68, 95, 99.7, that's usually pretty good. But try practicing filling this out, and then put in the numbers below here, and then the z-scores below. So if you were doing this with test scores with normally distributed test scores if you're doing this with test scores that were normally distributed with a mean of 70 and a standard deviation of 5, you would have 70, 75, 80, 85, and going down you'd have 65, 60, and 55, and then these are your z-scores below. So you could say, oh, what is a test score with a z-score of positive 2? Oh, 70, 75, 80. Positive 2. What percent of students scored above that? 2.5. Just add this up. What percent of students scored below that? 97.5. Just go down.